Now, let's go over the 2022 November exam for Physical Science Paper 1. Now, it says that grade P, you have two grades, grade P and grade 2. Now, grade P has a mass of 1.25 kg and Q has a mass of 2 kg. Now, they are connected by a light inextensible string. Now it says grade P of mass 1.25 is connected to another grade Q of mass 2 kg by a light inextensible string. The two grades are placed on a rough horizontal surface. A constant force F of magnitude 2.5. Now you have F equal to 2.5, 7.5 newtons acting at an angle theta to the horizontal is applied on grade Q as shown in the diagram below. They are placed on a horizontal surface. That means that on our surface here we'll have some friction. As soon as they say a rough horizontal surface, that means that the two grades, there'll be friction between the surface and the grades. Now, grade P experiences a constant frictional force of 1.8. So the frictional force of grade P is equal to 1.8 newtons. Now, if they are accelerating by 0.1 and they are being pulled by force F, that means that our friction acts in the opposite direction, which means that the friction will be in the left direction. Now let's note that the right is our positive. Grade Q experiences a constant frictional force of 2.2 newtons to the left because friction acts in the opposite direction to the motion. Now 2.1 says state Newton's second law of motion inwards. Now I will just state that and not write it down. We know that when a resultant force acts on an object, the object will accelerate in the direction of the force. Now, if you have a force with mass, that force you exert a resultant force, it will accelerate in the direction of the force. And the acceleration is directly proportional to the resultant force, but inversely proportional to the mass of the object. Now you can go on and read about that one, but it's essentially presented by this formula. Now 2.2 though. 2.2 says draw a labeled free body diagram for grade P. Now grade P is this one, and to draw a free body diagram we can represent it as, we can just do that and then represent the forces that are acting on our grade. This dot represents grade P. Let me just write it down. Now let's talk about the forces that are acting on our grade here. First, we know that since it is being pulled by grade Q, this force is pulling grade Q and grade Q is pulling P through this string. Therefore, it is experiencing a force that is moving to the right. Now, that force, since it is through a string or some sort of rope, it is tension force because it is being experienced through the rope that is pulling grade P. Now, another force that is that P is experiencing is because of the rough surface between the horizontal surface and grade P, which means that P will experience force of 1.8 in an opposite direction to its motion. Remember that they are accelerating at 0.1 meters per second square. So friction will act in the opposite direction of motion. Now, notice that I'm making the vector of friction smaller than the vector of tension. And that is because we know that it is accelerating to the right. Because of the force, it is accelerating by 0.21. So we know that whatever force is pulling it to that direction, it is stronger than whatever friction that is being experienced by grade P. Because if this friction was equal to the tension, then our grade would not be moving. Or if the force acting in opposite direction was greater than the tension, then it would move to the left instead of the right. So we know that this friction, it is not greater than the tension. You can name and say this is the tension, this is the friction. Now, because it has mass, that means gravity has to be exerting a force to grade P and pulling it downwards. Now, that force that gravity is exerting on the mass of grade P is called the weight. Now, it will experience a force going directly downwards called the weight. Now, the weight is a force that gravity exerts on the mass of an object. Now, we denote it with W. Now, because it is standing on a surface, there will also be a force that is perpendicular to the surface that it is acting upon. And we call that force the normal force. Now, notice that our grade is moving to the right. It's only moving in this x-axis dimension. It is not moving upward or downward. Therefore, the normal force must be balancing the weight. Therefore, they have to be equal in length. Our vectors will be equal in magnitude. Therefore, these arrows will be equal to show that there's no imbalance of forces in the y-axis. Therefore, it is not moving up or moving upward. And we say that force perpendicular to the surface is called the normal force. And now we have the free body diagram of grade P. Now 2.2.31 says calculate the tension in the string. Now since we have went all the way to find the free body diagram of P, let's try and use that for P. We know that in the x-axis that our tension is acting, we are looking for our tension. We also have the friction, so we need to find, we're using all the forces that are acting in the x-axis to calculate our tension. Now we are going to have, from Newton's second law, it says F net is equal to ma. Now what is our F net? Our F net, if we take right as positive, we know that our tension acts to the right. Therefore our tension will be positive. Subtract friction because it will be negative because it is acting to the left. That is equal to ma. M is mass, a is acceleration. Now, do we know the value of tension? We do not, so we still have T. But do we know the value of friction? We do, because they told us that P experiences a constant frictional force of 1.8. So we'll have subtract 1.8 newtons. Now remember, it is in newtons. I'm just not gonna, let's actually write it. Now that is equal the value of mass of P, which is 1.25, equal to acceleration. Remember, they're accelerating at 0.1 meters per second. Now this is kg, this is meters per second squared. Now I make T subject of the formula. I will just say I will have T equal to 1.93 newtons. Now this is my tension in the string. Remember that the tension in the string that is acting on P is the same tension that is acting on Q. So Q will also experience a tension of 1.93, but it will experience it in the opposite direction. So it will experience minus 1.93. 2.3.2 says calculate the angle Q. Now we are going to now look at the forces that are acting on grade Q, because the angle is at grade Q. So how can we calculate the angle? Is by also taking the Newton's second law, F net equal to ma, but now focusing on the forces that act on Q. Now the forces that act on Q, we said that the first one is the same tension that acts on grade P, so it will experience some tension T. Also, they told us that it experienced some friction of 2.2, so because of the rough surface, so it will also have its own friction of 2.2 newtons and a tension of 1.93 newtons. Now, since they're accelerating, that means that our force has a x component that is managing to pull everything to the right. So it will have to be longer than both the tension and the friction combined. So our x component of the force is managing to pull everything so that there's motion to the right. And that's all our forces in the x-axis. In the y-axis, you'll know that you have its weight and also the normal force and the y component of the force. The y component of the force. But we are interested in the forces that are acting in the x-axis. Now, let's write them down. We have tension, but our tension now acts in the opposite direction. It now acts to the left, and we said right is positive. So we'll have negative tension. We have friction, which is also acting to the left, so it is minus F. But we also have a x component of the force that is acting to the right, so that one is positive, and that is all equal to ma. Now we substitute the values. We know that tension is minus 1.93 because the tension on P is the tension on Q because it's the same string, and the friction is minus 2.2. But the force, the x component of the force, it is not 7.5. We only deal with the x component. So Fx will be given to us by F cos theta. Because if you look at this and you have a force here, it makes some sort of triangle like this where you have the y component and the x component, and you have theta here, and this is the force. Now to find the x component that is adjacent, it will be a cosine. So we have F cos theta, and we know our F is 7.5 cos, we do not know theta. That is equal to ma. Our m is the mass of the grade Q, which is 2 kg, and acceleration is the same, which is 0.1. Now we transpose this, we take them to the other side, we will have 7.5 cos theta equal to 0.2. If you transpose those to the other side, you will have positive 1.93 and positive 2.2. Now we only want cos theta, so we are going to divide both sides by 7.5 by 7.5, so that our cos theta is equal to 0.2 plus 1.95 plus 2.2 over 7.5. Now theta will be put that in there, and you find that your theta is equal to 54.74, and that's how you calculate